Given a function f of x equals 3x to the 3 plus 9x squared minus 7x plus 12. When we differentiate this function, get the derivative function, the gradient function f prime x, that will give us 9x squared plus 18x minus 7. So f prime x is the derivative function. Now integration is the reverse operation of differentiation. So we would start with the derivative function and integrate to get back to the function itself. There is a slight difference in that when we are differentiating a function, when we differentiate and find the derivative of a constant term, like 12 in this case, the derivative of a constant is 0. But when we integrate, we will perform the reverse of the procedure of differentiating, but we will need to include what is called a constant of integration. So we're going to be integrating 9x squared plus 18x minus 7 with respect to the variable which is x. And when we integrate each term separately as if it was a term on its own. Now when we differentiate, we multiply the exponent by the coefficient. 3 times 3 is 9, and we subtracted 1 off the exponent. 3 minus 1 is 2. Then we differentiated 9x squared. 2 times 9 is 18, and we subtracted 1 off the exponent. So at x to the power of 1. And then likewise, 1 times minus 7 is minus 7, and then we made x to the 1 minus 1, x to the 0, which is 1. And then 1 times minus 7 is still minus 7. Now when we integrate, we are going to be adding 1 to the exponent, and then we're going to divide the term by that new exponent. So we're going to add 1 to 2, 9x to the 3, and then we divide by 3, plus 18x, this is x to the power of 1, so we're going to add 1 to 1, which is 2, and then we divide by that new exponent, which is 2, minus 7, this is now x to the 0. We can add 1 to 0, so we'll have x to the 1, and then we divide by 1. But we don't leave the integration there, we have to add a constant of integration, which we call c. Generally, it's called c. And I'll explain that to you in a bit more detail in a bit. We'll just simplify this first. 9 divided by 3, 3x cubed, plus 18 divided by 2, 9x squared, minus 7x plus c. So this is now our function f of x. Now, with integration, we have what is called a family of solutions. So this constant here could be any constant. When you differentiate this expression here, regardless of the value of the constant, you'll always get back to the derivative function, which is 9x squared plus 18x minus 7. So regardless of the value of c, when you differentiate the function f of x, you'll always get this derivative function here. So, for example, if we had the function f of x equals 3x cubed plus 9x squared minus 7x plus 39, then we differentiate this function, we're going to get 9x squared plus 18x minus 7. The derivative of a constant is, regardless of the value of the constant, is always going to be 0. So that's why we have a family of solutions whenever we integrate a derivative function to find the original function. And that's the essence, that is the essence of integration. Okay, given a function f of x equals minus 5x to the 7 plus 9x cubed minus 13, when we differentiate this function, we get minus 35x to the 6 plus 27x squared, and the derivative of constant is going to be 0. Now we're taking this function, the derivative function, and we're going to integrate it to find the original function. So we're going to integrate f prime x with respect to x. The constant plays no part, okay, so you can just pull that out. We're now going to take the first term, x to the 6. we can add 1 to the exponent, so x to the 7, and then we divide by that new exponent, which is 7, plus 27, x to the 2 plus 1, so x to the 3, and then we divide by 3, but we also have to add the integration constant, so we add plus c. So this is now f of x. Simplify that, minus 35 divided by 7 is minus 5x to the 7, plus 27 divided by 3, 9x cubed, plus c. And again, it doesn't matter about the value of c, because when you differentiate f of x, the derivative of a constant is always going to be 0. So when we find the derivative function of this expression here, we get minus 35x to the 6 plus 27x squared. 17. The derivative function dy dx equals 12 times 5, that's going to be 60x to the 4, minus 7 times 2, 14x, plus 2 times 4, 8x cubed, and the derivative of the constant minus 17 is 0. We're now going to integrate this expression. So the integral of the derivative function is just going to be the function y. 60, we're going to add 1 to 4, so we have x to the 5 divided by 5, minus 14, x to the 1 plus 1, x squared divided by 2, plus 8x, and add 1 to 3, x to the 4 divided by 4, and then we add the constant of integration. So y will equal 12x to the 5 minus 7x squared plus 2x to the 4 plus c. And we can just tie that up with the expression that we have over here. The only difference is we have no idea of knowing what the value of c is, our integration constant. We'll only be able to know the value of c if we have a point that lies on this particular curve. So this represents a curve, and to find the value of c, we have to know one point that lies on the curve in order to find the value of c. And that's the essence of integration.